Assalamualaikum dan selamat sejahtera. Nama saya Nabi Ilyas bin Muhammad Bazli Jumani. Nombor matrik saya adalah 01DPU20F1022 dan rakan saya Muhammad Ani Syazwan bin Rosli 01DPU20F1030 dan Muhammad Hanif bin Mat Taha 01DPU20F1014. Hari ini kami akan membentangkan tentang topik 5 heat exchanger. Seterusnya 1.01 Introduction Heat Exchanger. A heat exchanger is a device that is used to transfer thermal energy enthalpy between two or more environments using a working fluid and working surface having different temperatures. Heat transfer can occur between a solid surface and a liquid, between solid particles and a liquid. The heat exchange or heat utilizing apparatus is one of the most common and important elements of power, utility and technological installations. Any conversion of energy from one type to another, as well as the transfer of energy from one device to another, is accompanied by the transition of a certain part of the energy to heat. Therefore, in almost all machines and apparatus, heat transfer is important. Heat exchanger play an important role in technological processes, energy, oil refining, manufacturing, transportation, air conditioning, cryogenic and recovery system. They also serve as key components of many industrial products available on the market. All heat exchangers can be classified according to various criteria. Next, 1.2 Heat exchanger thermodynamic. The design of a heat exchanger is an exercise in thermodynamics, which is the science that deals with heat energy flow, temperature and the relationship to other forms of energy. To understand heat exchanger thermodynamics, a good starting point is to learn about the three ways in which heat can be transferred: conduction, convection, and radiation. In the section below, a review of each of these heat transfer modes is presented. First, conduction. Conduction is the passing of thermal energy between materials that are in contact with one another. The rate at which heat energy is transferred in a material by thermal conduction is given by the following expression: Q over T equals Ka T divided by D. In this expression Q represents the amount of heat transferred through the material in time T. At is the temperature difference between one side of the material and the other, the thermal gradient. A is the cross-sectional area of the material and D is the thickness of the material. The constant K is known as the thermal conductivity of the material and is a function of the material intrinsic properties and its structure. A and other gases generally have low thermal conductivities, while non-metallic solids its higher values and metallic solid generally showing the highest values. And next, convection. Convection is the transfer of thermal energy from a surface by way of the motion of a fluid such as air or water that has been heated. For free convection, the rate of transfer of heat is expressed by Newton's law of cooling, which is Q dot equal to HC AT, where Q dot is the rate of the transfer of heat. HC is the convection heat transfer coefficient. A is the surface area over which the convection process is occurring, and At is the temperature differential between the surface and the fluid. The convection heat transfer coefficient HC is a function of the properties of the fluid, similar to the thermal conductivity of the material mentioned earlier regarding conduction. And the last, radiation. Thermal radiation is a mechanism of heat energy transfer that involves the emission of electromagnetic wave from a heated surface or object. The net rate of radiation heat loss can be expressed using the Stephen-Boltzmann law as follows. Q equal E O bracket T for H equal T power 4 C bracket AH, where Q is the heat transfer per unit time, TH is the temperature of the hot object in absolute units K, Kelvin, TC is the temperature of the colder surrounding, also in absolute units OK, Kelvin. O is the Stephen-Boltzmann constant, whose value is 5.6703 multiplied by 10 power negative 8 W per M power 2 K power 4. The term represented by E is emissivity coefficient of the material and can have a value anywhere between 0 to 1 depending on the characteristic of the material and its ability to reflect, absorb or transmit radiation. It is also a function of the temperature of the material. Next, 1.3 Basic principles underlying heat exchangers. First, the zeroth law of thermodynamics states that thermodynamic systems that are in thermal equilibrium have the same temperature, which is A equal to C equal to B equal to A. Second, the first law of thermodynamics builds upon the zeroth law, establishing internal energy U as another property of thermodynamic system and indicating the influence of heat and work on system internal energy and the surrounding environment's energy. AU system equal negative AU environment. The second law of thermodynamics establishes entropy as an additional property of thermodynamic system and describes the natural and invariable tendency of the universe and any other closed thermodynamic system to increase in entropy over time. AS equal to AQ divided by T.
Okay, my name is Mama Anif bin Mat Taha. My magic card 01 DPU 20F1014. Okay, this slide is about heat exchange design characteristic. As outlined above, all heat exchange operate under the same basic principle. However, this device can be classified and categorized in several different ways based on the design characteristic. The main characteristic by which heat exchange can be categorized include: first, flow configuration; third, heat transfer machine. Okay, the first is what is the flow configuration? The flow configuration, also referred to as the flow arrangement of a heat exchange, refer to the direction of movement of the fluid within the heat exchange in relation to each other. There are four principal flow configuration applied by heat exchange. Concurrent flow. Concurrent flow heat exchange, also referred to as parallel flow heat exchange. A heat exchange device in which the fluid moves parallel to and in the same direction as each other. Although its configuration typically result in lower efficiencies than a counterflow arrangement, it also allows for the greatest thermal uniformity across the wall of the heat exchange. Okay, second is about counter current flow. Counter current flow heat exchange, also known as counter flow heat exchange, are designed such that the fluid move anti-parallel to each other within the heat exchange. The most commonly employed of the flow configuration as current flow arrangement typically exhibit the highest efficiency as it allows for the greatest amount of heat transfer between fluid and consequently the greatest change in temperature. The third is about cross flow. In cross flow heat exchange, fluid flow perpendicularly to one another. The efficient of heat exchange which employ this flow configuration fall between that of the countercurrent and concurrent and current heat exchange. The next is about hybrid flow. Hybrid flow heat exchange exhibits some combination of the characteristic of the previously mentioned flow configuration. For example, heat exchange design can employ multiple flow paths and arrangement within a single heat exchange. This type of heat exchange are typically asked to accommodate the limitation of an application such as space, budget, cost, or temperature and pressure requirement. Okay, the next slide is below is illustrate the various flow configuration available, including a cross counter flow configuration, which is an example of a hybrid flow configuration. Okay, the first diagram is current flow, second is counter current flow, third is cross flow, and the last diagram is counter flow. Okay, the next slide is about heat transfer machine. There are two types of heat transfer machine employed by heat exchange: single phase or two phase heat transfer. In single phase heat exchange, the fluid do not undergo any phase change throughout the heat transfer process, meaning that both the warmer and cooler fluid remain in the same state of matter which they entered the heat exchange. On the other hand, in two-phase heat exchange, fluid do experience a phase change during the heat transfer process. The phase change can occur in either or both of the fluid involved, resulting in a change from a liquid to a gas or a gas to liquid. Typically, the device that employ a two-phase heat transfer machine require more complex design consideration than one that employ a single-phase heat transfer machine. Okay, type of heat exchange is based on the design character indicated above. There are several different variants of heat exchange variable. Some of the more common variants employed throughout industry include: first, pipe heat exchange; third, shield and tube heat exchange; third, plate heat exchange. Next is spiral plate heat exchange. and the lastly is spiral tube heat exchange. Okay, the next slide is about pipe-in-pipe heat exchange. Equipment consistent of two pipes with different diameter insert one into the other. Advantage and disadvantage of pipe-in-pipe heat exchange. First is the main advantage of the device of this design include high flow rate of the coolant. This is achieved through careful selection of water pipe of the desired diameter, which allow the medium to flow freely inside the pipe. Easy to maintain. This property makes it possible to carry out regular cleaning of equipment, which allow to increase the duration of the operation. Versatility in system, it is possible to add a coolant both in the liquid and in the vapor phase. The second is the disadvantage of the equipment. First, dimension. Due to the large size, difficulties arise during transportation and use of the device. Most of all, this refer to individual as where space is very limited. A second is high cost. The price of exchange pipe that are not involved in heat exchange and which are connected to the heat exchange is quick and brief. The third is difficulty in the design. When closing the equipment, you must contact the professional which is associated with the complexity of the calculation. At the same time, the overall cost of manufacturing and installation work increase.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Ali Shazwan Mirhusli. My IT number is 10DPU20F1030. So I want to present the shell and tube heat exchanger. The shell and tube heat exchanger includes a tubular tank and an integrated tubing section. The heat carriers in the heat exchanger are directed both parallel and toward each other. Advantage and disadvantage of shell and tube heat exchanger. The advantage is internal reliability. Shell and tube heat exchanger are more resistant to scale formation, which implies that cleaning should be done less frequently than with other heat exchanger. Possibility of power regulation. If necessary, increase or decrease the power. Adjust the number of sections, the length and diameter of the pipes. Long service life. Shell and tube heat exchanger have a long service life. The disadvantage is, first, large dimensions. A heat exchanger weight 120 kilogram and a length of 4 meter cannot always be fit and installed at the facility. The second, vulnerability of the outer part of the case. Tube heat exchanger are made of electric welded pipe. After a short period of work, the outer coating begins to diverge along the seam. Leaks appear, as a result of which oxygen begins to be released when the water is heated. This contributes to the development of metal corrosion. Number 3, efficiency. The coefficient is only 70%, which increase energy losses. Next, plate heat exchanger. They consist of a large number of corrugated plates made of stainless steel. They are separated by seals that are installed without the use of adhesive mixtures, but allow tight fit to each other. The advantage of plate heat exchanger. First, high efficiency. Due to the large area of heat exchange surface, the efficiency reached 95%, which is much higher than that of a tubular apparatus. Compactness. Second is compactness. The device is selected in accordance with the required heat consumption with a small number of plates. The differences will be less. Respectively, with a large number of plates, the difference will increase. Number 2, multifunctionality. Plate heat exchanger are used in many areas of life, have a wide range of capacities. Number 3, the cost of the device depends on the number of plates installed in it. There is the possibility of selecting the right number of plates. Repair costs replacing a worn plate and not the entire system. The disadvantage is, first, short service life. Plate heat exchanger are quickly clogged. The maximum service life without cleaning in 3 years. Next, spiral plate heat exchanger. Spiral plate heat exchanger are made of two metal plates that are one on each other. The advantage and the disadvantage is, first, single flow part reduce the rate of scale build up associated with liquid containing solids. Second, ability to work with two highly polluting liquids. Third, lack of dead zone for accumulation of solid particles inside the heat exchanger. Fourth, counterflow. Fifth, many alloys. Sixth, very low pressure drop. The disadvantage is design intellectual property of companies. A limited number of manufacturers. First, as a rule, the design is more expensive than other type of heat exchanger. Spiral tube heat exchanger. Spiral tubular heat exchanger are made of spiral pipes. The advantage and disadvantage of a spiral tube heat exchanger. The advantage is, first, compact and inexpensive heat exchanger requiring low power. Second, can withstanding high pressure. The disadvantage is design intellectual property of companies, a limited number of manufacturers. Next, we go to the calculation. So, given the counterflow heat exchanger, soalan dia suruh calculate the tube length necessary to perform the heat exchange requirement given below. Dia menggunakan liquid oil, and dia dah bagi dia punya given tu. So next, kita akan pakai rumus Q equal to U darab A darab perubahan T. Lepas tu yang kita nak cari L, so kita pindahkan L, jadinya Q divide by U pi perubahan T. So first kita kena cari perubahan T dulu. Perubahan T1 tolak perubahan T2 bahagi dengan ln perubahan T1 bahagi perubahan T2. Perubahan T1 T in oil tolak T out. So 100 darjah Celsius tolak 50 darjah Celsius, kita dapat 50. So perubahan T2 pula T out tolak dengan T in. So 60 darjah Celsius tolak 25 darjah Celsius equal to 35 darjah Celsius. So kita masukkan semula apa yang kita dapat tadi kepada formula perubahan T1 tolak perubahan T2 bahagi ln perubahan T1 per perubahan T2. So 50 darjah Celsius tolak 35 darjah Celsius ln dalam kurungan 50 darjah Celsius per 35 darjah Celsius. So jawapan ni sama dengan 42 darjah Celsius. So kita dah dapat perubahan T dia. So kita dah dapat antara yang dia dah bagi Q 12.786 U 38.1 D 0.03. So masukkan semula kepada formula yang kita dah ubah tadi pada awal tadi. L sama dengan Q divide by U pi D perubahan T. So masukkan Q dia 12.786 bahagi dengan U dia 38.1 darab dengan pi darab dengan D dia 0.03 darab dengan perubahan T yang kita buat tadi yang 42 darjah Celsius tu. So kita dapat 84.8 meter. So L parallel dia sama dengan 110.6 meter.
Next, 4.0 conclusion. In this slide, various types of heat exchanger used in industry. The criteria for the selection of devices depending on power and purpose are considered. Basically, they are made as condensers, evaporators, heaters, depending on the process conditions. That's all from us. Thank you for watching and stay safe. Assalamualaikum warahmatullahi wabarakatuh.